Let's study now the mean values theorem. Don't confuse the mean values theorem with the intermediate values theorem, okay? These are different things. So the mean values theorem, here the hypothesis is that f is continuous and differentiable in the interval a, b. Okay, if that happens, then there exists a number c in the interval, in the open interval ab, such that f prime at c is equal to f of b minus f of a divided by b minus a. What does this mean? Let me show you with a picture what is the meaning of this theorem. So let's say we have, let's make it a little, there we go. Let's say we have a function f of x like this, okay? And we have a point A and a point B, just as in the theorem, okay? And we have f of A, f of B. All right, so what is this quantity f of b minus f of a divided by b minus a? So that quantity is the slope of this line over here. The slope of this line is how much height we gain, which is f of b minus f of a, divided by the distance we take to gain that height, which is b minus a. Okay, that's the slope. And what the theorem is saying is that if I copy this line here, see what happens. Let's change to a different color. Let's say I move it around. Did you notice what happened there? There is one point, C, where the derivative of the function f, the slope of the tangent, is precisely the slope of the red line, f of b minus f of a divided by b minus a. Okay, here the slope of the tangent is f prime of c. Okay, so this is what the theorem is saying. It's saying that the slope of the tangent is equal to the average slope f of b minus f of a divided by b minus a at some point inside the interval. Now, there is one very special case that we need to know. Important special case that is called Rolle's theorem. And in this case, it's as I say, it's very similar. You have a function that is continuous and differentiable in AB, okay? And f of a equals f of b. Okay, the function is equal at a and b, the value of the function. These two are satisfied, then there is a number c in AB such that f prime of c equals 0. Okay. So now, what is the picture for this theorem? This theorem says that if you have a function, here you have your f of a equal f of b. Okay, this is your a, this is your b, and you have a function that goes up and down, or maybe Maybe it's the other way around. Maybe instead of going up, it goes down. Okay, or maybe you have something wavy. What the theorem is saying is that there is a point, if it goes up and then down again, there is a point where the slope is horizontal. Okay. There may be just one or there may be more. Okay, the theorem doesn't say. The theorem says there is one, but it doesn't say there could be, if that one point is unique or there could be more. Okay, you see from the pictures that that is possible. So there could be several possibilities for C. Okay, so in this case, we can call them C1 and C2. Okay. So one thing here, very important, is that the theorem, and this requires a warning, the theorem does not say how to compute or how to find C, okay? And there is a second warning. We may think, hey, does this work for continuous functions? Do I really need the function to be differentiable? I do. What happens with these theorems is that when you drop one of the hypotheses, then who knows? Okay, but we can find cases where it won't work if we drop the differentiability. For example, the easiest is if we have a function with a corner. Okay, let's say 1 minus the absolute value of x. Okay. So here you have f of 1 equal f of negative 1. Okay. And the question is there c in negative 1, 1 with f of prime of c equals 0, as the theorem says? The answer is no. Okay, because is there a tangent? You can see it on the picture. Is there a tangent that is horizontal? No, because you start with a slope, well, not c, f of prime of x equals 1. You finish, no, you finish, no, that's not correct. Then the derivative jumps to negative 1. And there is nothing in between because f of prime at 0 is not defined. Well, not defined, no, does not exist. Okay, so we need to be very careful, because if the function is not differentiable, then there is no, the change in the slope may be very abrupt, and then we may not find the f prime as we want.